In this video, I'm going to be talking about polynomial inequalities, specifically inequalities that have degree greater than or equal to 3. And this is going to be lesson 2 in Unit 8 of College Algebra. In the first semester of this course, we solved linear inequalities, which were really easy, right? It was right at the beginning when we were dealing with one variable. We just kind of solved for x, just pretending that the inequality wasn't there and then dealing with it at the end. So we would say that, something like 2x is less than or equal to 2, and then we would divide both sides by 2, and x would be less than or equal to 1. And so, that would be very straightforward, right? Here's 1. We're interested in this. Easy enough. Then when we studied the quadratic functions, we took a couple of techniques at this. One was just kind of like know what the zeros are, know that this thing's going to be a parabola that opens up, and color in where it's less than 0. Well, here's where it's equal to 0, and here was where it was less than 0. Okay, so that traced back to x being between 2 and 4. But then we also kind of introduced, especially if you were not in my section of College Algebra, if you were in somebody else's section of College Algebra, you may have made a little number line, split it up at the zeros, chosen a little representative, say 3, 0, and 5. And then you would kind of plug in, okay, 3 minus 2 is a positive number, 3 minus 4 is a negative number, positive times negative is negative. And then you would say for 5, well, both of these things, x minus 2 and x minus 4, would both be positive, so they're both positive, and if x is 0, I'm multiplying negative by negative, which is also positive. And I'm interested in where this thing is less than 0, so that's going to be through here. Okay. Both of these techniques are equivalent. It depends on what you like. But then when we did the rational inequalities, we don't really want to draw a graph of y equals x over x plus 2, or even a sketch of it, because that was unpleasant. So what we did was we made a number line. We plotted the zeros of the top and the bottom, because those were the places where, oh, whoops, that's going to be negative 2 and 0. Because those were the only places where the sign could change. And then we would just kind of, plug in some numbers like I was talking about before. So this is negative 1, say negative 3, and 1. And then, okay, when we go and plug them in, like start with 1. 1 over 3 is a positive number. You plug in negative 1, I've got negative 1 over positive 1 is negative. And then negative 3, I've got negative 3 over negative 1 is a positive number. We're interested in where this was greater than 0. Okay, well, that meant that we were looking for these intervals, right? This is the same technique that I'm going to recommend for higher degree polynomials, is to use the sign chart. I really think that's the safest for where y'all are at this point. If you are feeling really comfortable with sketching the graph of a polynomial, you are welcome to do that, to solve it, this way, where you sketch a graph and do that. That's what I generally do with my calculus classes, is just sketch a graph, look at where it's above the x-axis if you're trying to solve greater than 0. Really just depends on your level of comfort with sketching these polynomials. And today we're going to solve polynomial inequalities with degree greater than or equal to 3, like x to the third minus x is negative, or less than or equal to 0, not positive. Well, what we got to do here is, first we got to factor the thing, no matter what, whether we're going to make a number line or whether we're going to draw a sketch of the graph. So I'm going to factor this thing first. And so there's a greatest common factor of x, and I'm left with an x squared minus 1. And x squared minus 1 is factorable. So that's x plus 1, x minus 1. So now I have x times x plus 1 times x minus 1 is less than or equal to 0. So I know what the zeros are. It would be 0, negative 1, and positive 1. On one hand, I'll do the number line technique. So I'm subdividing my number line at the zeros of the polynomial. And then I'm going to just, choose a representative from each subinterval. So negative 2, negative 0.5, positive 0.5, and 2. Then I kind of test those numbers out. What happens when x is negative 2? Okay, well, x is negative 2 is negative. Negative 2 plus 1 is negative. And negative 2 minus 1 is also negative. I have 3 negatives, that's a negative. Any odd number of negatives is going to give you a negative product. Then negative 0.5. Okay, I'll plug in negative 0.5. X is negative. X plus 1 will be positive, and then negative 0.5 minus another 1 will be negative 1.5. Okay, I've got 2 negatives, that's making a positive. At positive 0.5, x is positive because x is 0.5. X plus 1 is positive. But x minus 1, if I take a half and I subtract 1, that's going to be negative. So I've got 1 negative that's going to be negative. And then at x equals 2, well, 2 is positive. 2 plus 1 is positive, and 2 minus 1 is positive. And then we're interested in where this thing is less than or equal to 0. It's equal to 0 here. And it's less than 0 wherever I'm seeing a negative sign. So it's there and here. So the solution is x is less than or equal to negative 1. Or maybe x is between 0 and 1. Okay, alternately, if you're really comfortable with sketching the graphs of these things, okay, I know this is a third degree polynomial with a positive leading coefficient that has zeros at negative 1, 0, positive 1. They are all single roots. They all have multiplicity 1. And so that means it's going to come from below, kind of pass through confidently, pass through confidently, pass through confidently, no bouncing. And then if I'm interested in where this is less than or equal to 0, well, that's where it's below the x-axis. Okay, so that's where it's equal to 0, less than 0. Equal to 0, equal to 0, less than 0. See, that's the same thing. That's x is less than or equal to negative 1, or x is between 0 and 1, including 0 and including 1. Okay, however you like it. For the rest of this video, however, I'm going to be using the sign chart method. All right, so the first example from your note packet is x minus 1 times x minus 3 times x minus 5 is negative. So what we're going to do is we're going to cook ourselves up a little number line. We're going to divide it, splitting at the zeros of the polynomial, so 1, 3, and 5. And this polynomial seems familiar. I think this one was like the same one from the notes last time. So I'm sure we've made this sign chart before, but it's just how it goes. Then you just choose a representative from each subinterval. So that's 0, 2, 4, and 6. And then you kind of test out each of them. So 0, 2, 4, and 6. Okay. When x is 0, I have negative 1 times negative 3 times negative 5. So that's negative times negative times negative. It's going to be negative. At x equals 2, 2 minus 1 is a positive number. 2 minus 3 is negative. 2 minus 5 is negative. Okay, 2 negatives is positive. Positive times positive is positive. At x equals 4, I'll have 3 times 1 times negative 1. It'll be a negative number. And at x equals 6, it'll be 5 times 3 times 1, which is going to be positive. And since less than 0 means negative, I'm interested in these regions here. And so that's x is less than 1, or maybe x is between 3 and 5. Oh, and one thing I forgot to mention on the previous example is that you could write these as an interval also, if that's how you felt. I know a few of y'all prefer that, so and that's an option. It's the same thing, just dressed up differently. So x is less than 1 is x ranging from negative infinity up to positive 1. And then 3 to 5, but not including 3 and not including 5, is going to be like that. So either one of those is okay. And on the quiz, if you do that, both of those should be counted correct. Next, I've got one with some repeated factors. I've got x plus 8 squared multiplied by x plus 5 multiplied by x plus 7 squared being less than or equal to 0. Okay, so I'm going to make myself a little number line. I'm going to split it at the, so I've got 5, 7, and 8, or negative 5, negative 7, and negative 8. And I'm going to choose a representative from each little subinterval. So, maybe negative 10. That's going to have to be negative 7.5. The pen's kind of acting up. And that would be negative 6. And here I would choose 0 just for convenience. So, negative 10, negative 7.5, negative 6, and 0. All right. Now the thing is, with x plus 8 squared and x plus 7 squared, those are both always going to be positive. The only time they wouldn't be positive is when there's 0, which would happen at one of our splitting points, but those are not the points I'm testing. So I know that the first factor and the third factor are always going to be positive. Okay. Then with x plus 5, okay, just plug in each of the x's. Negative 10 plus 5 is a negative number. Negative 7.5 plus 5, also a negative number. Negative 6 plus 5, still negative. 0 plus 5, that's positive. Okay, so we're going to say that this is, okay, it's looking like negative, 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 positive. We're interested in where this is less than or equal to 0. So I'll fill in where it's equal to 0 first. Okay, it's equal to 0 at these points. That's why they're points we're including on our graph. It's because they're the zeros. It's where the sign could potentially change. And then I'm interested in where it's less than or equal to 0. So less than is negative. That's in here, and here, and in here. Meaning that really I'm willing to take anything that's less than negative 5, right? Everything is covered. So I'll say x is less than or equal to negative 5. If you wanted to write this as an interval, you would say this runs from negative infinity up to negative 5. Now we want to include negative 5, so we're going to use a squared bracket. But you don't include negative infinity because negative infinity is not a real number. And so you use a curve bracket. Again, whatever you like. Okay, skipping ahead, kind of in the interest of time, to one that says x to the fourth minus x squared minus 30 is negative. Okay, I want to bring this one back up because this is that kind of new factoring object that we had not encountered in the past. And so I just want to practice that. We're going to need to factor this in x squared. So we're basically going to factor it with x squared plus some number and x squared plus some other. So we're still looking for two numbers that are multiplying to negative 30 and adding to negative 1. And that would be negative 6 and positive 5. And if you need to check this again by FOILing, you should, pause the video and do that. But you can see that it's going to be x to the fourth, negative 6x squared plus 5x squared minus 30. It works like that. So the zeros of this thing are going to happen. I need to do a little more work. I need to say, okay, x squared minus 6 equals 0 when x squared equals 6, which happens to be at the square root of 6, and maybe also the negative square root of 6. X squared plus 5 is 0 when x squared is negative 5. But x squared can't equal negative 5 if x is a real number, so that's not going to contribute a 0. So on my number line, I have negative square root 6 and positive square root 6. And that's really all I've got. Those are the only zeros that this fourth degree polynomial has. All right, got that cleared out of there. And I'm going to choose a representative from each. That's 0. Okay, as far as the square root of 6, I don't know what the square root of 6 is, but I know it's bigger than 2, and I know it's smaller than 3, because 2 is the square root of 4, and 3 is the square root of 9. So, okay, if you wanted to, you can just choose something that's like clearly going to be bigger than the square root of 6, like 100 and negative 100. But you could also just choose 3 and negative 3. That's what I'm going to do. So you kind of try out x equals 3, or negative 3, 0, and positive 3. Okay, when you plug in negative 3, you're going to get 9 minus 6 is a positive number, and then 9 plus 5 is a positive number. And if you think about it, x squared plus 5 is always going to be a positive number. If you're confused about why that is, just, try a positive number, try a negative number, try 0, try the square root of 5. It's always going to come back positive. Anything you square, it's going to come back positive or 0, and then you add 5 to that, it's certainly going to be positive. Okay, 0 squared is 0, minus 6 is negative 6, that's negative. And then when you plug in regular 3, that'll be 9 minus 6 is 3. So I've got positive, 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 negative, and positive, positive. I'm interested in where this is less than 0, so it's going to be right in here. The answer would be negative square root 6 is less than x is less than square root 6. Or maybe you write it as an interval. Doesn't matter to me. All right, the last one I got for y'all is one where we're going to have to group and factor. I think it's good for us to practice that as well. So I'm going to start by grouping and factoring. So I factor out an x squared, x minus 1, and then I'm going to need to take a negative 3, x minus 1, and then I factor out x minus 1. All right, and the zeros that this thing's going to contribute is going to be 1, and then, I'm going to have to do a little work over here. X squared minus 3 equals 0 when x squared equals 3. So that means x is either the square root of 3 or the negative square root of 3. All right, and this one you might, consider possibly, I don't know what the square root of 3 is. I know it's bigger than 1.5 because 1.5 squared is 2.25. But, maybe you write this as a decimal. You bring out a calculator and do that. If you're wanting to do that, no big deal. I know 1.5 is between 1 and the square root of 3, so I'm just going to do that. And then I'll say, well, square root of 3 is certainly smaller than 3, so I'll just use 3 as my kind of test point. And then 0 and negative 3. And now I'm going to go over here and I'm going to start testing. Negative 3, 0, 1.5, and 3. When x is negative 3 minus 1 is negative. 9 minus 3 is positive. When x is 0, I've got negative 1 times negative 3. When x is 1.5, I'm going to have 1.5 minus 1 is a positive number. And if I square 1.5, that's 2.25 minus 3 is going to be negative. 3 minus 1, 9 minus 3, yeah, ready to go. Okay, I'm interested in where this thing is less than or equal to 0. So it's equal to 0 here. And it's less than 0 through there. So my solution is going to be x is less than or equal to the negative square root of 3, or maybe x is between 1 and the square root of 3. Whoops. And if you wanted to write that as an interval, it would look like this. And there you go. Now I'm going to have one more for you. So this one, it's not in your notes packet, But I feel like there's a couple of things that it has that I want to talk about. First of all, it is not just an inequality that's set to 0. Remember, when we did all of these other ones, that was kind of central to what we were doing. Was first we set the inequality to 0, then we factor the results. So I'm going to do that. So it's x to the 4 minus 25x squared is greater than or equal to 0. And then I'll factor out the greatest common factor is x squared times x squared minus 25. And then that's more factorable, so that's x plus 5 and x minus 5. We're interested in where this is greater than or equal to 0. So I make myself a little number line. Split it at negative 5, 0, and 5. And I choose some numbers to test with. I'll choose maybe negative 10 and negative 1, 1, and 10. When x is negative 10, I'm going to have negative 10 squared is 100, so that's a positive number. Negative 10 plus 5 is a negative number, and negative 10 minus 5 is also a negative. So two negatives, that's making positive. Negative 1. Okay. Negative 1 squared is positive 1. Negative 1 plus 5 is positive. Negative 1 minus 5 is negative 6. Okay, I see one negative, that's going to end up negative. At x equals 1. Okay, 1 squared is 1. X plus 5 would be 6. And x minus 5 would be negative 4. So this one's negative again. And then at x equals 10, I've got 100, 15, and 5. All positive numbers, so it's going to be positive. And just to remind you of something from last time, it shouldn't be a surprise that we didn't observe a sign change here at 0 because of this double root, this multiplicity 2 thing here. Okay, we're seeing a repeated factor. So it's not going to give us a sign change. So I'm interested in where this is greater than or equal to 0, and that's the other thing. So, okay, it's equal to 0 here, here, and there, and it's greater than 0 out here. So, yeah, I'm pretty sure that y'all would get x is less than or equal to negative 5, and x is greater than or equal to positive 5. But you also need to account for x equals 0, because we're interested in where this thing is greater than or equal to 0. So at 0.1, it's negative, and at negative 0.1, it's negative. But at x equals 0, y is equal to 0. So this inequality would be true, because, and then if you go back and look at the original one, right, this x to the 4th minus 25x squared, you plug in 0, 0 is greater than or equal to 0. Because it's equal to 0. So that's just, one kind of weird one that I wanted to make you aware of before the quiz next time, right? I wouldn't want you to get caught off guard or anything. And at this point, you've got all the tools you need. You need to go back into that example packet, and you need to work all of them, okay? And then if there's any that you have a problem with, come and see me in the morning, or ask a question when we go to do practice problems before the quiz next time.